Yeah.
The radius, now we're finding that sine cosine is dual.
Exactly, yeah. It's like for the tangent of 60, you got what? 1.7321. Perfect. So if you get those trig functions, what that is saying is it's not giving you the sides of the triangle at all. What it is saying is if I have a right triangle, and this angle right here is 60 degrees, this would be which side? It's a leg, but it is more specifically the opposite leg. This would be adjacent. And of course, this one's hypotenuse. Sine, anybody remember what the ratio, what the two sides are for sine? Opposite over hypotenuse. So what that is saying is the ratio of length of this side to this side is 0.866. It's not telling you how long either of those sides are. It's just saying if I take the length of this side divided by the length of that side, it is 0.866. Cosine, do you remember what two sides that compared? That's adjacent over hypotenuse. So that's looking at this side compared to this side. Again, it's not telling you how long either one of them is. It's just saying that this side is half of what that one is. Or 0.5. Then, of course, tangent was opposite over adjacent. So that's saying, again, the ratio of this side to this side. Doesn't tell you how long either one of them is. It's just saying that this one is 1.7321 times whatever this one is.
These functions just help us up the proportions we need for the
Exactly.
figure it out.
So we still have to know the length of one of the sides. Once we know the length of one of the sides, then these ratios allow us to find all the other sides from that, because we know the relationship between them. Let's see how much you remember about secant. If you guys remember, secant isn't on your calculator. But how did we remember that we found a relationship between secant and one of the other trig functions? Yes, sir. Cosine. The cosine of an angle is the adjacent side compared to the hypotenuse. The secant of an angle, I'm just throwing in 60 again, is the hypotenuse over the adjacent side. They're reciprocals. So there's two ways we can go about it. One way we could go about it was just doing 1 divided by the cosine of 60 degrees, which will give you the answer. But remember, we discussed a second way that was more effective. Yes, sir.
Like, use cosine with like the -1 by.
You got, well, not the cosine -1. It's the x -1 key. It's called the reciprocal key. Your calculator either have that x -1 key or a 1 over x key like this. And a more effective way to do the secant is to find the cosine of 60. Closing your parentheses. And then you're hitting that x -1 key. So it would look something like this. Cosine 60. Close my parentheses. Then I'm hitting my x -1 outside. Now some of your calculators might actually just put the -1 up there as a power. Remember that power of -1 is just saying reciprocal. So what it'll give me now should be 2. Did you guys get 2 to come out?
I got a different number when I put 1 over. I don't understand.
If you want to go back, can you show me where
The reciprocal key is?
Yeah,
Sure. So you type in cosine 60, make sure you close your parentheses, then hit the x -1. You get it to work now, Jared?
yeah.
Okay. So that comes out to be 2. Now there's a reason why I have you do this set of keystrokes, because when we go to do an inverse trig function, we got to use that x -1 key to make it work. Back in the days, we didn't have calculators. I mean, when I was in school, we had them, but for the first so many days that we worked on stuff, we did. We had in the back of our book, there's about 30 pages worth of tables that listed out degree by degree.
I have a machinist handbook in my toolbox
Sure.
that has all the tables in the back.
And they would list it out, you know, Some of the tables only went every 5 degrees. Some went every degree and gave the sine, cosine, tangent. So if you wanted the secant, you'd have to look up the cosine and then you'd have to actually do out by hand 1 divided by that number and work it out.
And you have minutes and seconds.
Yeah, the minutes and seconds, if you had a really detailed table, if you were like a mechanical engineer or something, you'd have a table that'd go down to like 15 seconds. Yeah. It was like a 4-volume book, like an encyclopedia set almost. And then you also, they call it extrapolation, where if, let's say that your table only went down to the nearest degree and you had 32.6 degrees. Well, how do you extrapolate between 32 and 33? Yeah. The good old days.
And he's just grinning.
You guys can grin about it too, because I'll never make you do it.
Good. I got man keep you all.
I'm going to have you, though, try the cosecant of 60. So what other trig function is associated with cosecant? The sine. So reciprocal of the sine. So you do the sine of 60. Close the parentheses, and then hit that x negative 1 key, which will give us
1.1547.
There we go. 1.1547. And finally, cotangent. That's the easy one to match up. Here's what keep going. First, that is the reciprocal of the tangent. Point. 5.774. Now, these, the secant, cosecant, cotangent. In practical applications, you can avoid them for the most part. There are some formulas out there. Your basic geometry stuff that you're looking for, finding missing dimensions and stuff, you can avoid them. There are some formulas for advanced electronics and stuff like that in circuits that require them. So you'd need to know this. But the tricky part to remember, of course, cotangent goes with tangent. That one's easy to remember. But the secant and cosecant almost seem backwards. Because you would think secant would go with sine and cosecant would go with cosine. But it doesn't. That secant goes with the cosine. So you got to remember that. So that might be one of those things in your notes. I told you yesterday you should have somewhere in your notes, you should have this list. Sine of an angle is equal to opposite side over adjacent side. Cosine of an angle, adjacent side over adjacent. Opposite over what? Hypotenuse. Thank you. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Cheat sheet?
Yeah.
The secant is the hypotenuse over the adjacent. Now I would add to that on the back of your chart. It's the reciprocal of cosine, 1 over cosine. Of course, the cosecant is the hypotenuse over the opposite. And again, I would add to your little table that is 1 over sine. And our cotangent is adjacent over opposite. I'd recommend you add to your little table, that's 1 over the tangent. So now that we have all those out there, oops, where'd it go? Come back here. We may have situations like I just gave you, where you're given the angle and you need to find the trig function. More common, however, is where you have an angle. I'm going to call this angle A, this angle B here. And we have the dimensions on that triangle. For example, let's say that this here is 8 millimeters. This one's 15 millimeters. Now, since we know this is a right triangle, we could find the hypotenuse if we wanted to. How would we find the hypotenuse here?
A squared plus B squared is C squared
Okay. Yeah, this here would be called side A. This would be called side B. The sides of a triangle are named from its opposite angle. Side A is related to this angle. Remember, the bigger angle is across from the bigger side, smaller. Actually, the other way around. The bigger side's across from the bigger angle, smaller side's across from the smaller angle. So we call that side A because it's related to angle A. This, of course, then would be our angle C, and this would be side little c. So yeah, the length of C squared is equal to A squared plus B squared. I'm going to let you guys punch that in for me quick and tell me the length of side C. Bless you. What'd you get? 17. Perfect. And of course, everything else is in millimeters, so that'll be in millimeters as well at this point. So now with that triangle, if I ask you, I'm going to get some of this stuff out of the way so you got some room to write. Just so I keep my triangle on the screen. If I were to ask you, what is the sine of angle A? Well, you can't punch this in your calculator because you don't know angle A. But you can use those ratios. Okay? Sine is what two sides? Opposite of hypotenuse. What would be the opposite? Now remember, opposite and adjacent are not set parts of the triangle. They depend on which angle we're looking at. So if we're looking at angle A, the opposite side is 8. The adjacent side is a 15. So the sine of A would be opposite, which is 8 over hypotenuse of 17. So 8 over 17. Right now we're just going to leave it as a fraction. You could divide it out and get your 0.4 or whatever it comes out to be. Cosine of angle B. So here's angle B. According to angle B, what's now the opposite side? The 15. And the adjacent side would be the 8. Well, cosine is adjacent over hypotenuse. The adjacent side is the 8. The hypotenuse, well, that side never changes. That's still 17. Coincidence. The sine of A is 8 over 17, and the cosine of B is 8 over 17? Is that just a happy coincidence, or is there a reason for it? Very good. In a right triangle, the two non-right angles, the A and B in this case, have to add up to what? They have to add up to 180, or add up to 90. Thank you. You had me for a second there, Cody. They have to add up to 90. Which means they're complementary, they're complements. The word cosine means the sine of the complement. So since B is the complement of A, the sine of A, or the cosine of B, has to equal the sine of A. Because A is its complement. So cosine of B is asking what is the sine of its complement. In other words, what's the sine of A? So they have to be the same because they're complements. You look really confused, Jason. You okay? Okay. So then what if I were to ask for the tangent of angle A? Now again, first you got to identify which angle we're looking at. Which angle are we looking at here? My screen just went really funny there. There it is. We're looking at this one, angle A here. So then tangent, of course, is what two sides? Opposite over adjacent. For angle A, which one's the opposite? 8. The adjacent is then, of course, the 15, the other leg. So 8 divided by 15, if you want to divide that out into decimal, will give you your tangent. Just for fun, what's the secant of angle B? Remember, secant is hypotenuse over adjacent. Well, the hypotenuse is 17. Which one is the adjacent side? We know it has to be either the 8 or the 15. We're looking at angle B, so the adjacent one is 8. So 2.125. Cotangent of B. Cotangent is adjacent over opposite. This is angle B. Which one's the adjacent side? 8 would be adjacent to it. So the opposite side is 15. Once again, you'll notice tangent and cotangent. Cotangent of B is equal to the tangent of A. Those are some relationships we're going to explore more as we go through the next couple of weeks, because those are huge. I mean, it saves you a lot of time if you know what the sine of 15 degree is and you have to find the cosine of 75. You've already got it, no need to punch it back in and do some more calculating with it. The main reason we're doing this stuff, though, is we've used the calculator once we have the angle to find what the trig function is. Now we can go the other direction. I'm just going to give you this time, instead of making it a squared plus b squared equals c squared for the hypotenuse. Let's say we have a right triangle with the hypotenuse of 10 and legs of 6 and 8. I'm going to just label it A, B, C. So this, of course, is little a, little b, little c. And I want to find angle A. Well, at this point, we haven't talked about it yet, but you have all the information you need. If we knew angle A, we've got all the sides, so we use whatever trig function we want to. I always default to sine because sine is the first one you usually learn, and so it's the one I always default to. If I were looking at the sine of angle A, if I knew the angle, I could just punch it in my calculator. Off of this triangle, though, what's the sine of angle A? 8 divided by, sine is opposite over hypotenuse, 8 over 10, which would be 0.8 exactly. We spent quite a bit of time first semester solving equations. If we had 3x equals 21, how did we solve that equation? Yeah, what we did is we looked at the equation and we asked ourselves, what's done to the variable to build this equation? And this equation, it was built by multiplying x by 3. So the variable was multiplied by 3. To take it apart or to solve it, we did the opposite. The opposite of multiplying by 3 is dividing by 3. We call that inverses. So dividing by 3, it literally undoes or cancels out the multiplying by 3, leaving us with just x. Dividing by 3 over here gave us 7. But what we have down here is just an equation. This is sine of, if I wanted to think of that variable, that angle as x, sine of x is 0.8. But now our variable has not been multiplied or divided by something, and it hasn't had something added or subtracted to it. It has had the sine taken of it. So we need to know what is the opposite function, or the technical term is the inverse function for sine. Now when we were doing secant and cosecant, a lot of you were saying, hey, I've got this button on my calculator that's sine -1. Won't that do it? No. This is what that button is for. That sign with the -1 there is an abbreviation for inverse sine. Sometimes called arc sine. Arc sine is an old notation. Old, it's the way I was taught. So it tells you how old it is. Based off of that unit circle we talked about on Monday. The sine, or the angle itself, remember, is specifying an arc on the circle. Also, it's saying what is the arc related to that sine. So it's just an old-fashioned notation. Anyway, inverse sine. If I want to find out what this is here, I have to cancel out the sine. I have to undo taking the sine of that angle. And I do it by doing the opposite, or the inverse. So the inverse sine and the sine cancel each other out, leaving with just x here. But on the other side, I must also do the inverse sine. So I'm doing the inverse sine of 0.8. On your calculator, the way you make that work, you'll see that that sine -1 or inverse sine is above the sine key. It's the second function or the shift function, depending on your calculator. So to do that, you're going to do second or shift, the sine -1, and then put in the 0.8. And you get what? 53.1301. Now, when we're doing angles, when we're doing trig functions, we want to go to 4 decimal places. When we're doing angles, it's sufficient to go to 2. So I'm going to call that 53.13 degrees. So we can use these trig functions, the ratios of sides on the triangles, and then the built-in functions in our calculator. Now that you have them, you don't have to use the tables anymore, to find what that missing angle is. And I think this is what you were kind of getting at before. Yeah. So I want you to try this. In this triangle, I'm not even putting any units in there. I want you to find angle B. Now, in my previous example up here, I had given you all 3 sides. So you'd pick whatever trig function you wanted to use. In this example, I was just a little bit trickier. I only gave you 2 sides. I only gave you the 15 and the 28, which meant you couldn't just pick any trig function. You had to figure out which one matched up with those sides. So according to angle B, the first thing we have to figure out is what sides we have. Now, I always look to see if we have the hypotenuse first. Do we have the hypotenuse? Which side is the hypotenuse? 28 is the hypotenuse. So all that's left is the 15. It's one of the legs. It's either the opposite or the adjacent. And again, that depends on the angle. So since we're looking at angle B, the 15 is the opposite. It's across from it. It doesn't touch it, so it has to be the opposite. If you look up in your little chart of all your trig functions, which trig function involves the hypotenuse and the opposite? There's actually 2 of them that involve those 2 sides. One is the secant, or sorry, not secant, the cosecant, which is hypotenuse, or yeah, hypotenuse over opposite. But we don't have a cosecant button on our calculator, so we just ignore that one. The other one was sine. So I'm going to write this out. Sine of an angle. I'm using x today because that's what your packet uses. Normally I would use theta, is what's standard, the Greek symbol theta that we talked about Monday for a generic angle. The sine of an angle is the opposite over the hypotenuse. I'm writing out the definition first to make sure I've got it right. And now I fill in what I know. Do I know x? No, that's what I'm trying to find. That's angle B that I'm trying to find there. Do I know the opposite side? It's 15. Do I know the hypotenuse? 28. So now to find angle B, what I'm going to punch into my calculator, I have the sine of B. I need to do an inverse sine. So I'm going to do an inverse sine. 15 divided by 28. So second sine. 15 divided by 28. Now here's where you have to remember to close your parentheses on these functions. If you don't, some of your calculators will still catch it. Some of them will mess it up. And we get 32.39. 92. So 32.39. No. 32.39 degrees. So next step, I'll have you try. I want you to find angle M if I give you those sides. So, angle M's right there. Do we have the hypotenuse? Say no, yeah. We don't have the hypotenuse. So we're dealing with both legs. So we have an opposite and adjacent leg. Which one of those legs is the opposite? 37 is the opposite. Which means, of course, 41 is the adjacent. If we have opposite and adjacent, we have two trig functions again that involve those two sides. One is tangent, the other is cotangent. Well, our calculator doesn't do the cotangent, so we are stuck with tangent. Again, I'm going to write out the definition. Tangent of an angle is opposite over adjacent. And now I'm going to fill in our information. Do I know the angle? No, but I know it's called M, so I'll fill in the M. Equals, do I know the opposite side? Say 37. There we go. Do I know the adjacent side? 41, that's better. So now how would I punch this in the calculator? Yeah, second or inverse tangent of 37. Perfect. So second tangent 37 divided by 41 equals 42.06 you get? Perfect. Find angle P for me. Okay, so again, I'm going to ask, do we have the hypotenuse?
Yes.
Yes, we do. Okay, that's the 31. Obviously, the other side we have is a leg. Which leg is it? Adjacent, because it is touching our angle, or next to our angle. Hypotenuse and adjacent can either be secant or cosine. Cosine of an angle is the adjacent side over the hypotenuse. When you're starting out, I know you don't want to do it. I know you guys hate writing down anything more than you have to. But I highly, highly, highly recommend every time, once you've identified the sides and you've picked out which trig function you're going to use, write the definition down. Because having that definition there avoids a lot of mistakes. Because once it's there, all it is plugging numbers in. Now, cosine, of course, is just a function. There's nothing I can plug in there. Can I plug anything in for x? No, it's P. I'll put in my angle P, right? But I can't put any numbers in. Can I plug something in for the adjacent side? That's my 13. Hypotenuse, 31. Other word of warning while we're here. Make sure those units are the same. If they're not the same, make them the same. But it's a ratio, and it's not a ratio if it doesn't have the same units, same labels. So now, calculating that out, I'm not going to write it out here now. I'm just going to punch it in. What keys do I hit?
You just go second cosine 13 divided by 31.
Perfect. Second cosine gives me the inverse cosine. 13 divided by 31. Close my parentheses. 65.21. So P equals 65.21 degrees. So now at this point, I am relatively confident that you guys can handle these next three problems I'm going to give you. What's the head? I'm going to give you the sine of A is 0.2338. Find what angle A is. Cosine of B, 0.7141. Find out what angle B is. And tangent of angle M is 3.824. Find out what angle M is. So for sine of A equals 0.2338, I'm going to do inverse sine. So second sine, 0.2338. I'm going to close it just to be safe. Hit equals, and we get?
It'd be 13.52.
You are correct. 13.52 degrees. How many people got that? Anybody did? Perfect. For the cosine of b equals 0.7141. Second cosine 0.7141. Close the parentheses equals?
44.43.
Good job, Cody. 44.43. And for the tangent of m equals 3.824, it's going to be second tangent for inverse tangent. 3.824. Close parentheses. Hit equals, we get?
75.34.
Perfect. 75.34 degrees. Now, I want you to put your calculators down for a second. Don't punch this one in. If I tell you the sine of angle D equals 1.325. Can you tell me what D is?
Yeah. Just gotta get 17.
Say no. No, why not?
I don't know enough.
You don't know enough? It's not that you don't know enough. It's kind of like asking if you're a good enough hunter to find the pink Bigfoot. There isn't one, right? Remember, unit circle, pretend that's a circle, has a radius of what? 1. That's its definition. So, whatever angle D is, let's say it's somewhere in here, the sine is this length here. That's the sine. So if this is angle D, this will be the sine of D. Well, I can't write today. Well, the longest that could be would be this length right here, right? How long is that? 1. Can the sine ever be bigger than 1? No. This doesn't exist. Bless you. Pick up your calculators once and punch that in. Inverse sine or second sine, 1.325. Your calculator is going to give you a happy little message like error.
Error.
Yeah. If you ever get that, that's what it's telling you, is that trig function cannot possibly take on that value. Sine and cosine both have to be between -1 and +1. Because when you get over here, even though it's less than a unit long, it's on the negative side of the graph. So the cosine would be negative. The sine is still positive. And we'll go over those over the next week or two. We'll talk about positives and negatives. Jason's getting overloaded already.
Yeah. Cramming too much stuff in my head,
Just a couple more little things to complete the torture for the day. Now, if cosine has to be less than 1, let's see, between 1 and -1. Secant, since it's 1 divided by cosine, has to always be 1 or larger. If cosine can never be bigger than 1, 1 divided by something that's smaller than 1 has to be larger than 1. So if I give you secant of A is equal to 2.437. We don't have a secant key in our calculator. We don't have an inverse secant key. We have to do it in terms of cosine. The cosine of A would be the reciprocal of that, 1 divided by 2.437. Remember, cosine and secants are reciprocals. So the way we calculate an inverse secant, because what we really want here is this. The secant inverse of 2.437. And again, our calculators, the good people at Texas Instruments or Sharp or Casio, did not see fit to give you that key. So what you have to use is the inverse cosine. So you're going to use that second cosine or inverse cosine. And this is where that reciprocal key, that x -1 key comes in again. You're going to put 2.437 in here. Now, this is the big difference. When you're finding the secant, you close the parentheses and then you hit the x -1, right? When you're finding the inverse secant, hit the x -1 first, then you close the parentheses. Okay? So on my calculator, I'm going to do second. I got to clear that out. Second, cosine for inverse cosine, 2.437. Now before I close the, oops, something worked. Second, cosine, 2.437. Before I close those parentheses, I got to hit the x negative 1 key. Then I'm going to close the parentheses and hit equals 65.77 degrees. What do you guys think? How many of you are looking for that sharp stick right about now? You found one. You ready? So if cosecant of b equals 0.936, how do I find b? So you're going to use the sine instead of, right? It's cosecant.
Yeah.
So you use sine, you say? The inverse sine of 0.936, do the x negative 1 in there. Okay, what's it give you? What's it give you?
You'll be in here.
Why?
It's smaller than 1.
Yeah, it's smaller than 1. Secant and cosine. Sine and cosine must always be smaller than 1, between 0 and 1 or between negative 1 and 1. Which means secant and cosecant must always be larger than 1. You cannot have a cosecant of 0.936. I know I'm not very nice. Let's try that again then with a number that'll work. Cosecant of b, 1.8932. Find b. You get what? 31.88. In your packet, starting on page 341, continuing on to page 342. Starting with problems number 54, going up to problem 122. Yeah, I know that's a lot. Again, just do the odds. Or do every other odd if they're going well. Work on those. Now remember, this is Wednesday, which means you have your hour next door, which means there is a little quiz to take.
Does it have to be Monday? Over and over on Monday?
No, it does not. The quiz to take, the way it's going to be done is it's going to be extra credit. When you take those quizzes, I'll look at your other quizzes and I'll add points to any of the other quizzes or tests that you're missing, or if you've got perfect tests and quizzes, I'll just put in an extra credit grade for you. But it's very, very, very much to your benefit to take these quizzes. Today's quiz is a very good one for you.
These are notes.
Yes, you need your notes, your books.